Good evening, everyone. We'll just wait for a minute for more participants to come in and then we'll begin. Thank you for joining.
We'll wait for others to join in, then we can just begin in a minute.
All right, Hetal, shall we begin?
Yes, we can begin. Good evening, everyone. I want to begin by appreciating your presence. Welcome to today's webinar on unpacking illusions and confusions in science, misconceptions to mastery. We are delighted to have you with us. For the next hour, we will take a deep dive into exploring the misconceptions that students often face, which hinder their understanding, particularly in science, grade 7 to 10. By the end of the session, I hope you'll feel equipped with the insights and tools that make science classrooms more meaningful, where misconceptions transform into opportunities for deeper understanding. So this webinar has three objectives. We will dive into misconception diagnosed in ACID 2025. The agenda will cover the following key points: understanding what misconceptions are, discussing why it is crucial to identify and resolve them, exploring common misconception with specific example, and finally, we will be sharing a success story of a school that effectively remediated these learning challenges. Let me begin by introducing myself and my colleague. My name is Hetal Parmar. I'm an academic consultant with EI with over a decade of experience in teaching special education and counseling. I work with individuals of varied needs. I am joined by my colleague Akanksha Sawant, who is an associate educational fellow with content development team at EI. She holds a master's degree in biology and in education. She's worked as an educator and researcher at Homi Bhabha Center for Science Education, Mumbai, prior to joining EI. Both of us worked at a leading pet tech organization called Educational Initiatives, which is a 23-year-old company with a vision to create a world where every student learns with understanding. Our vision purely stands on three key pillars, that is pedagogical research, leveraging cutting edge technology to enable learning, and science of learning. Together, these elements guide our mission to transform learning experiences for students. At EI, ACID is our flagship program, which is a test designed to be diagnostic. It is not about marks, but about insights. It helps schools answer vital questions. How do we compare with others? Do our students truly understand concepts, or are there any gaps? Are there misconceptions blocking their learning? How can we as teachers improve learning instructions? ACID uncovers not only what students get wrong, but why they think the way they think. This is what makes it different from regular assessment. It's a window into student thinking. Every year, we have more than 5 lakh students take the test in which is summer and winter since the past 23 years. Coming to the benchmarking is one of the most powerful features of ACID. It allows school to compare their students' performance with peers across the country. Thinking of it as holding up a mirror, it shows us where we stand, where others are, what gaps exist. For teachers, this data is invaluable. It helps us move beyond intuition and anecdotal evidence and instead make instructional design backing by facts. For example, benchmarking can reveal that while a class scores are high in factual recall, they may lag in reasoning skills compared to national averages. This insight shifts the focus of teaching. Benchmarking then is not about competition, it is about growth. It empowers school to track progress year on year, celebrate strengths, and systematically work on areas of improvement. That is why we say benchmarking is not just testing, it is a roadmap for better learning outcomes. Moving on, in ACID, the testing, like we mentioned, goes far beyond checking the recall of facts. It focuses on three key dimensions. First, benchmarking, which helps help schools understand their performance in comparison with national peers. Second is misconception, where assessments are designed to uncover hidden gaps in student understanding. And third, teacher effectiveness. The data reflects classroom practices which shape student understanding. And with all these three coming together, these insights definitely go beyond marks. They help school and teachers see what's wrong, what isn't, and actually how do we guide our children towards real learning. With an understanding of ACID now, let's try to understand what misconceptions are. Over to you, Akanksha.
Thank you, Ethel, and good evening, everyone. So let's start by understanding what a misconception is, because that's going to be the premise of our entire webinar today. So, a misconception is an incorrect or an incomplete understanding of a concept. These can come from everyday experiences, from the way language is used in a subject versus day to day life, or even how a concept has been taught in the past. What misconceptions do is they cause wrong assumptions and error in thinking when knowledge has to be applied later. And that is why misconceptions are not simple mistakes. They are deeply held wrong beliefs that require correction as early as possible so that learning can be meaningful. Right? Now, before we go on to understanding misconceptions in science, Hetal, can you help us understand how science is as a subject and how we treat it at EI?
Yes, yes. So, science, what we believe, is not just a subject, it is a lens through which curiosity transforms into discovery and misconceptions into mastery. So, what we think of science is an empirical field of study. What this means is that knowledge in science develops through observations and experimentation. This also makes knowledge obtained objective and logical. For example, the concept of gravitation. If you drop an object from a height, it will fall towards the ground, no matter where you are in the world, what language you speak, or what culture you belong to. All in all, science is a process of continuous discovery that connects isolated facts into a comprehensive understanding of the natural world. It is a process of discovery that definitely connects both of it, and through academic testing in science, we are not only just testing the concepts but also the skills. So, what do we actually test, right? The concepts and skills, what I spoke of, the concepts widely range from life sciences and physical sciences to scientific literacy. But our focus is not only what students know, but it's actually on how they think. We assess four key skills. First, the knowledge of basic facts. Second, the conceptual understanding and comprehension. Third, reasoning and analysis, the ability to apply knowledge in new situations. And fourth, original thinking, where students can hypothesize, design an experiment, or think beyond what is thought. With this deeper lens of science, learning, and asset, let us now move forward where Akanksha will take us into the world of misconception in science, and we will be exploring a few examples.
All right, great. So, misconceptions in science are a little difficult because they often rely on everyday experiences that children have of the world around them. For example, they say that the sun moves around the earth, not the earth that's moving around the sun. And it seems correct because it's based on what they see. They also feel that that plants take in food from the soil. And it seems logical because you can see roots under the soil, right? So reasoning based on intuition and observable but misleading experiences make science a very fertile ground for misconceptions. So let's try to understand what research says about misconceptions and how they come about in science. Okay, so Jean Piaget, a lot of you may have heard of it, must have studied his theories as well, was a Swiss psychologist known for his extensive work on child development and learning. What he said is that children experience the world around them, and based on these experiences, they create some very primitive, naive theories of how things work, right? Now, when they repeatedly experience the same thing, the brain starts looking for patterns and jumps to conclusions. For example, if they see a spoon and a piece of paper falling, and they see that the spoon is falling faster, they think that heavy objects fall faster, right? So that's a conclusion that the brain has made. And these theories are very hard to extinguish because a student has observed these things. Children observe this, they've experienced it, and that is why they are difficult to extinguish in their minds. Now, even if an educator tells a student that no, heavy objects don't fall faster, all objects fall at the same rate if there is no air, the mind doesn't believe it, right? The mind wants to stay in equilibrium because this is what they've experienced. So they go ahead and discredit what new information is coming in and stick to what they know. And that is the reason it's extremely important to address misconceptions as early as possible so that they don't go ahead and get amplified, right? Now, in science, misconceptions, like any other subject, is an inaccurate idea that's not based on a scientific fact, right? So sometimes it can occur due to oversimplification, using scientific terms, for example, weight and mass interchangeably, or there can be a difference between how a word is used in science versus how it's used in everyday life. Now, all these simple things can create major science misconceptions as well. So, in the next few slides, let me take you through some of these broad categories of misconceptions. And I'm very sure a lot of you will relate to it because you would have experienced these yourselves as teachers. Let's look at this first question here. The question is describing the law of reflection and is asking students in which situations is this law going to be true. Now, we know that the correct answer is all right. Let me before I get to the correct answer, let me quickly request that we launch a poll. Let's have the first poll and let's see what you think students will respond before I tell you what the correct answer is. So think of it from their perspective. What will they answer if they answer this question? We'll take about 30 seconds to answer the poll. All right, let's take 15 seconds more. I hope all of you are answering the poll. We'd like to hear from everyone. All right. Can we stop the poll now? Okay, interesting. So 59% of you feel that students would have gone in for option B. 16% think they would have said A, 22% think C. Interesting, interesting. All right. So very, I mean, a lot of you are very aligned with what students actually went ahead with. So the correct answer is A. But we can see that 50% students went in for option B, wherein they feel that this law is applicable only if the surface is plane. Now, this could be because a lot of textbooks, when we introduce the law of reflection, show it in the perspective of only a plane surface and not an irregular surface. And so it develops this incorrect idea that the law of reflection is true only if the type of material and the shape of the surface is plane, right? So, incorrect ideas that arise because of not knowing concepts clearly are called conceptual misunderstandings, and it's the most common form of misconceptions, right? Let's look at another example. The question is talking about the moon set time. So it's saying that the moon set at 12:15 a.m. post midnight on the 16th of February. And the question is asking what time did the moon rise? Okay. So students who understand the moon and the sun cycle will know that it's a 12-hour cycle. So if the moon sets at 12:15 a.m., it is likely to have risen around 12 hours before that, which would be on the 15th of February, the previous day at 12:05 p.m., right? But when we looked at responses, only 13% were able to get this right. Almost 70% students went in for option C or option D. So they got the date wrong between C and D, but they were very sure that the time is 7 p.m. This is probably because they've observed mostly the moon at night or they've observed it rising whenever the sun sets. And this category of misconception that arises because of some earlier experience that we've had are called preconceived notions. This is another very common category of misconceptions in students. All right. Let's look at one more example. So the question is asking students to identify which statement is a scientific observation. Okay, so there are many mango trees here. That's an observation. I am sure there will be many birds in the park. That's not an observation. It's more of an assumption or a prediction, right? We should not throw trash in the park. That's more like an opinion again. My doctor told me that mosquito bites can cause malaria is an informative statement, or you could say it's like a concluding remark from the doctor, right? But it's not an observation. The only observation here, scientifically, what we call an observation, is something that you can see or measure, right? And that is, there are so many mango trees here. When we look at student responses, about 30% got it right, which is not bad at all. But what's worrying is that 41% felt that my doctor told me that mosquito bites can cause malaria, which is just an informative statement, is actually a scientific observation. Now, this is another category of misconceptions that arises because of the way the word is used in day-to-day life versus what it means scientifically. In day-to-day life, you say, I observe this, I observe that, even if you've not observed it. Okay, if it's just a piece of information, we tend to call it an observation. And the misconceptions arising because of language are called vernacular misconceptions. Okay, I'll take you through three more categories, and these are slightly smaller categories. Teleology is another one, and it mostly comes up when we're talking about evolution, So whenever students tend to explain natural phenomena through the lens of a purpose, like saying giraffes have long necks so that they can reach higher trees. That's not true, right? They don't have longer necks so that they can reach. In fact, they're able to reach the higher trees because they have long necks, right? So the way the first sentence was said and the second sentence was said mean vastly different things in science, where one is correct and one is a misconception, right? The next category is what is called anthropomorphism, wherein we are attributing human characteristics to non human entities. So, when we're saying things like the stem likes the sunlight, or we're saying an atom wants to be stable and that is why it gains an electron, we're attributing desires to an atom, which is a non living entity, right? So, that category, when students explain it in this manner, that's called anthropomorphism. Okay. And the third category is overgeneralization. This is another category that causes a lot of misconceptions. When we say all metals conduct electricity or all metals conduct heat, all metals are magnetic, that's not true, right? We have a lot of exceptions. And those exceptions are not spoken about when we're initially talking. The generalization is given first because it's easier to remember, but that eventually ends up causing a lot of misconceptions unknowingly. Hetal, wasn't this interesting?
Yeah, definitely. In fact, I was wondering, Akanksha, that you've been creating acid questions, and I think we all would love to know that what is that exactly you keep in mind while creating these kind of questions.
Sure. So, this is also one question that we often get when we are visiting schools to talk to students and teachers. One very important consideration is the concept being covered and the skill that we're trying to test. We've said that ACID is a skill based assessment, and that forms the backbone of every question that we create. So, suppose I want to create a question that's testing students' understanding of how digestion happens, right? Now, by class A, they're expected to know what digestion is, which food categories are digested in which part of the digestive system. So, we created this question, and so when we're creating the options, I'll tell you what things we take care of. But at this point, let me just pause and quickly let's launch a poll. Poll number two. Teachers, would you be able to identify what skill this question is testing? It's asking students to identify which of the food items given um, are broken down during digestion. Okay, so try to identify what skill this is. Is it knowledge of science facts? Is it understanding, reasoning, original thinking? I'll, I'll give you 10-15 seconds here. All right. Can we stop the poll now? And let's see what teachers have said. Very,
I'll
very
say,
interesting.
yeah, very interesting data. We have 42% of teachers thinking it's a conceptual understanding and comprehension. 33% of teachers say
Yeah,
it's reasoning and analysis. This is exactly what we call it as a setup of a common wrong answer, right? With varied options selected by teachers. Yeah.
right. So this question does require knowledge of facts, but it's going a little beyond and testing whether students are able to comprehend and demonstrate that understanding. Right. So the skill that was being tested, which a lot of you said correctly, is conceptual understanding and comprehension. And let's try to now look ahead. So the correct answer in this case, like we all know, is option C, which is rice and orange juice. Now, since digestion involves the breakdown, water does not need to be broken down further, right? It is a simple form and it gets absorbed as is in the blood. Rice needs to be broken down, it's a carbohydrate. And orange juice, although it has simpler sugars, it does have food that needs to be digested or broken down before it gets absorbed, right? Now, when we were crafting the incorrect answers or what we call distractors, we have to look at what are some incorrect ideas that students may have, and based on that, create these distractors. So, for that, of course, we have a huge bank of asset data, quantitative data from past papers. We talk to students to get this information, and there's a lot of reading that goes into creating questions on student misconceptions. So, based on that, we created our distractors, and we think that students are likely to go in more for option A because they may think only solid foods need to be digested, and liquids are already in their simple form, digested form, and they don't need further digestion. The ones who select B, we think may think that water is needed for digestion, and so it undergoes digestion itself. But we also think that these are students who must be guessing, and students who go in for option D, we think will choose that because they think anything that passes through the digestive system needs to be digested. But that's not true, right? We take in glucose because it doesn't need digestion. And that's why it gives us that quick energy, right? So let's go ahead and look at what student responses said. So student responses gave us the same it aligned with what we were thinking, and almost more than half of the students went in for option A, which we anticipated would be the common wrong answer. Now, before I go ahead, I have to mention at this point the rigor that goes into creating these questions. Uh, After the question maker has created the question and before it is administered, there are five more people who review the question, and only then, once everyone is satisfied, it goes out into a paper for the student.
That's truly, truly extensive and very detail oriented. So now let's take a look at some of the misconception questions from ACID 2025. In this segment, we'll focus on two types of questions. First, a concept-based question where students need to apply their understanding of a concept to arrive at the correct answer. The second are skill based questions where students can solve them purely using skills like observation or logic without relying on prior conceptual knowledge. Now, this does not mean that concept based questions don't require skills. In fact, they demand higher order thinking skills such as comprehension, critical thinking, and problem solving. By examining both these type of questions side by side, we can clearly see the difference and also recognize why both are important in strengthening students' understanding.
All right. So when we were looking at misconceptions from the summer round of 2025, the first major pattern that we saw were incorrect ideas based on the understanding of properties of matter. Okay, now this question basic is based on the skill of reasoning and analysis. I'll just explain this to you. So there is a setup here, two flasks. The first one has a sugar solution, the second one has a salt solution. This person, Kirtana, tastes this solution in flask 2. After tasting, she adds the connecting tube and switches on the burner. Now, what's happening is the sugar solution is getting heated, vapors are forming, moving from the connecting tube into flask 2. After a few minutes of this happening, she again tastes the contents of flask 2, and the question is asking her what will she experience? Will flask 2 now have a less salty solution, a less sweet solution, a mix of sweet and salty taste, or no taste at all? Okay. Now we know that when we're heating the solution, water vapor will rise, move into flask 2, and dilute the solution a little bit. And that will result in a less salty solution. It was salty earlier, now it will be salty but less salty. And that is the correct answer. 27% students were able to get that. But 42% students thought that it will be a mix of salty and sweet. Now, sweet didn't exist in flask 2, but they think that when this is vaporizing, it's not just water vapor that will get transferred, but also sugar will vaporize and move into flask 2, which is not correct, right? It's an incorrect idea and something that needs to be addressed, right? Now let's look at another question. This question is trying to ask, it's based on the concept of displacement of water and it depends on volume. So the question is asking students to predict in which of these beakers will there be a rise in the water level? In the one where sponge is added, the one where cotton is added, or the one where iron is added, or all three of them. Okay. Now, at this point, can we have poll number 3 launched? Let's try to understand from the teachers in the audience, what do you think students will answer um, if we ask them this question? Let's launch poll number 3. All right, teachers, let's take 10 more seconds. All right, can we stop the poll and let's see what teachers have said?
Wow, very
Okay.
interesting. Option
Oh,
A, only
yeah.
iron is chosen by most of our teachers, of thinking of students.
Absolutely. This is very encouraging because teachers know the pulse of their students. They know that students are going to go in for only iron,
Correct. Hmm.
and which is exactly what our data also showed us. Option D is correct. The water level will rise when all three of them are added because it's matter. Matter has volume and it will lead to displacement of water. But a huge percentage, 72%, that's three quarters of the students who've answered this question picked option A. So they think that sponge and cotton will not cause a rise. Now, it is, I mean, what we need to understand is that sponge and cotton will absorb water, but there will be a net increase in the amount of water. It may not be as much as iron, but there will be a rise in the level of water. Now, when we look, we asked a very similar question to class six, but it tested a little more basic idea. What is responsible for the increase in the level of water? Is it mass or is it the amount of space or the volume? So we asked students, this is the initial level in each of these containers, this dotted line. And then you add a cricket ball here, a robot here, and a pyramid here. And then this was the increase. So there was the highest increase where the toy was added, the least increase where the pyramid was added. And the question asked, what can be said about the objects from this experiment? Now, the correct answer is that all the three objects occupy different amounts of space. But when we looked at performance, we found that 40% students said option B, which means they thought that this displacement is happening not because of volume, but because of different weights or different mass. Now, misconceptions of these kind can affect their understanding of Archimedes' principle, buoyancy, and density calculations in higher classes, where this volume displacement relationship is extremely important, right? So, Hetal, at this point, any tips or strategies, interesting strategies that our educators can use to address such misconceptions?
Definitely. What at this stage we looked at is at creating a cognitive conflict using guided inquiry learning. This process has four stages. First, in the orientation step, the teacher sets the stage with a problem statement. For example, solids occupy space when immersed in water. They displace it. But does cotton behave in the same way? Next, in conceptualization stage, students predict and form a hypothesis. They may say that cotton absorbs water, so the water level should fall. Then comes the investigations phase where students test their prediction by dipping the cotton and a metal ball into water and carefully observing the changes in water level. And finally, in the conclusion stage, they discuss and reflect. The results show both cotton and metal ball raised in water level, but cotton gave a lesser rise since it absorbed the water.
Interesting.
So, what we also do is on the right side of the screen, you can see a logo, which we call it as try after test, which is a reminder for the teachers to give students opportunity to go beyond just answering the test question. For example, your students see vessels filled with water and marbles being added. So instead of stopping at a MCQ level, teachers can actually encourage them to try out similar experiments with water and objects. This helps students verify concept, explore different possibilities, and build deeper understanding. So the logo signals that learning continues after the test through reflection, hands-on activity, and curiosity. Teachers, please do encourage your students to try the feature, try after the test.
Absolutely. I'll just implore everyone to look at the question paper once the test is done and look out for questions that have this try after the test logo. These are questions that you can actually try out in the class and get students to answer questions only after trying, not just by reading and answering. All right. Now, the next pattern that came through was incorrect ideas related to reproduction. So now this question here for class 8 is discussing the three types of pollination. So P is talking about pollination, self-pollination, but within the same flower. Okay. Q is talking about pollination from one flower to another, but in the same plant. And R is talking about cross pollination. So that is one flower to another flower of two different plants, but the same species. And the question is asking in which of these methods of pollination will you get an offspring that is identical to the parent plant? Okay, now here it's important for students to understand that we're talking about sexual reproduction, right? And when we say sexual reproduction, there is going to be variation, and so the offspring cannot be identical to the parent plant. So the correct answer is option D. And I'm going to show you data from last year and this year because we repeated the question this year to see what is the change in performance. And there was no change in performance. The same number of students marked option D last year and this year as well. So that's only 9% that got it right. All the other students picked between option A, B, and C, signaling that there's some confusion in their understanding of what will be identical to the parent plant and what won't, right? Maybe they think that because it involves only a single parent, there will be no variation happening, but that is not true, right? Let's look at another question, class 9. Which of the organisms in the list reproduce sexually? Again, the correct answer here is option D, whether it's an insect or mammals, any kind of animal, as well as plants, they all undergo sexual reproduction. But maybe when we're talking about sexual reproduction, textbooks, when we also talk about it, we are mostly referring to mammals or animals in general. And so maybe students think that plants do not undergo sexual reproduction. This also may explain their performance in the previous question. They're likely to think that plants don't undergo sexual reproduction at all, right? Let's look at one more question in this category. So students are shown three unfertilized eggs from three different animals, P, Q, and R, and they're asking them which statement is true. Okay. Now, the first statement is the number of cells of each of the three eggs is the same, which is true, right? They'll all have just one cell. Next is egg R has a greater number of cells. That's not true, right? Uh, Adults formed from the three eggs will have the same number of cells. Again, we cannot say that. May or may not. Organisms producing egg Q is bigger than the organism producing egg P. Okay, so we're trying to see if students relate the size of the egg to the size of the organism itself, right? And rightfully so, only 29% of students felt picked the correct answer. 39% students said that egg R has a greater number of cells. That means they're relating size to the number of cells. So if it's big, it has more cells. If it's small, it has lesser cells. At this point, they're not even taking into consideration what they've learned multiple times about egg cells, sperm, gametes are all single cells in their unfertilized form, right? So at this point, I think we'll go ahead and try to understand how can we, um, what do we do to address um, this gap in learning?
So, Akanksha, what we at EI think and understand is right. When students have these learning gaps, one very powerful way to address them is through Socratic method. This method isn't about actually giving ready-made answers, right? Instead, it's about asking probing, open-ended question that push students to think deeper. For example, a teacher might ask, "What can we say about this phenomena?" or "What assumptions are you making?" What do you base your reasoning on? Such questions actually encourage our students to reflect, clarify their ideas, build stronger reasoning skills. So, both in this case, teacher and student take part in the inquiry, making it a dialogue rather than a lecture. So, in this way, Socratic method helps bridge cognitive gaps by promoting curiosity, understanding, and critical thinking. So let's actually go ahead and look at an example. So we can say start by establishing the basic by asking questions like, what do we mean by an unfertilized egg? Or is it a baby animal or a single cell? Then we move on to challenging the misconception, like whether a bigger egg actually means more cells. Using comparisons such as one small balloon versus one large balloon helps students see that size doesn't always equal to number. So finally, we connect to familiar experiences like the chicken egg most students have eaten, or does that represent just one large cell or many cells? So these kind of questions actually make students think critically and connect concepts to their everyday lives and correct misunderstanding in a very natural way, right? So to support this kind of questioning, teachers, we can also use ready-made worksheets and teacher sheets, which are available from our side on the Diksha portal. Over to
Right.
you, Akash.
All right. So now the next few set of questions that we'll see, you'll notice that the pattern emerging is that the questions tested very basic science concepts. Now, for example, this question is asking students to identify that when a plant is growing, where is all that mass coming from? Is it coming from the light from the sun, minerals from the soil, water from the soil and air, or is it from carbon dioxide from the air? Right now, in the reaction of photosynthesis, carbon dioxide and water combine to give you glucose, but water mainly contributes to the formation of oxygen. We've established that in the first line here. We've given that information to students. So it should be easy for them to deduce using their prior knowledge as well that all the mass comes from carbon dioxide in the air. But it's only 17% that can make that deduction. 35% students and then another 28% students think of minerals from the soil or water from the soil and air. This brings me back to that initial conversation where I told you that because they see roots in the soil, they think everything, all the weight, all the food that's being made is coming from the soil. And they cannot really relate to something invisible like air contributing to that weight of the tree, right? All right. Another question in this category asks students to identify which of the three materials, candle wax, water, and iron bar, can exist in all three states. Okay. Now, a lot of students here went in for option A because they've seen water existing in all three states. They've seen ice, they see water, and they've seen steam. They've also seen candle wax existing in three states. So when you light a candle, you can see molten wax, you can see vapors coming from the candle, And so either they think water or both water and candle wax. But only 10% students at class 8 think that iron can also exist in all three levels. Now, only because they've not experienced it, they don't believe it, right? But any substance can exist in all three states of matter. It may be in very different laboratory conditions, but they can exist. And that understanding is missing in students right now. Okay, let's look at another question related to the concept of force. The question is asking students to identify what forces will act on the ball that this boy is throwing after he throws the ball. Okay. So the force of the throw in this case will not act on the ball once the ball is thrown, right? It will act to start the motion, but once the motion has started, it will not act on it. What will act on the ball is the force of gravity and the air resistance. So only two and three. But a lot of students, almost like more than half, think that either they miss that the force of the throw will not act because it goes against Newton's first law of motion, or it's also possible that they've missed the word after in the question, even though it's highlighted, but they've missed it and they just picked all the three forces acting on the ball at some point, right? So, and this is the reason why we recommend that it's important to go back to the class and discuss questions with students and understand why they are arriving at a certain answer, because that will tell you what is the misconception exactly. Did they just not read the question properly, or is there an actual misconception underlying? Right? Hital, what do you think about that?
Yeah, definitely. I think it's important to create a structure to do these discussions. Like, we definitely should select MCQs that came up as misconception or also as questions from earlier acid round. And what we can actually go ahead and do is ask our children to explain how they arrived at the answer, because that is where the misconception will break open. And then we can actually address these through discussions or experiments or both.
Absolutely. So discussions, having classroom discussions are extremely important. And that is why even we go in for student interviews, because just data gives us one part of the picture. But doing these student interviews gives us a much better understanding of how students think, and they help us make better questions. All right. So let's go ahead and discuss a last few set of questions. Now this question here, if you can see, there are two clay blocks, okay, identical clay blocks. An identical glass block is placed on these clay blocks in different orientations. Okay, the question requires the student to predict what's going to be what will be the compression of these two clay blocks. Will clay block one be compressed more because there's more pressure here? Will this be compressed more because there's more pressure on clay block two? Or will both clay blocks be compressed to the same extent because pressure exerted on them is the same? All right. Now, this question is trying to test students' understanding of pressure and testing if they realize that pressure is inversely proportional to area of contact, just the area of contact. But what students have probably gone ahead and thought is that because in clay block 2, this area of the entire base of the glass block is less than this, they think pressure will be more because there's an inverse relationship. What they've not realized is that the area of contact is the same in both cases, and so pressure exerted will be the same and compression will be the same. All right, let's go ahead and look at this question. This is a very interesting question. Personally, I really like this question. The question is showing two circuits with two bulbs arranged in different manners. So here it's like a continuous circuit. Here there is a staggered manner of the circuit. The question is asking once the switch is closed, what will happen? Okay. It's trying to see whether students have the incorrect idea that if there is a difference between the length or the distance between the bulb and the source of electricity, will they glow at different times depending on that? Now let's look. let's look at student responses. 20% said D. That is, current will start flowing through the entire circuit at the same time. There's going to be no difference in the time at which the bulb will get switched on, right? But 35% students felt that here bulbs will light up at the same time, but here they will light up at different times because this is closer and this is farther away, right? So this is also, I mean, one wouldn't think that this will also come up as a misconception, but this also is a common error that students are making. All right. Okay. Another question. This question is asking students to just pay attention to the picture and identifying what can be observed. Okay, it's sort of imploring students again and again and reiterating that observation is what you see, hear, or notice, not what you assume. Okay, let's quickly launch poll number 5 here and let's try to understand, teachers, what do you think students will go in for? Let's quickly respond to this. I'm sure you're already, even before I launch the poll, identified what students will mark as the wrong answer. But let's put it here and see what you all are saying. It'll take about 10 seconds more. All right, can we stop the poll now? All
Very
right,
interesting.
yeah,
Again, very interesting data between A and D, one being the correct answer and another being a misconception.
absolutely. So the two answers that most of you have picked, A and D, one is the correct answer. It has a translucent body, and that is something that can be observed from the picture. What cannot be observed from the picture is that it has sticky feet that help it climb smooth surfaces. And almost 57% students have picked that because they looked at the picture, it looks like a frog, so they assumed that it's going to have sticky feet. And that is the entire difference that we're talking about here. When we are doing experiments, when we are trying to make scientific citizens or scientifically literate citizens, we want them to be very careful about what to focus on. So, in experiments, it's very important to focus on what can be observed and not assume things based on what we know already, right? And that's an important skill, not just for a science student, but for any student or any individual for that matter, right? Okay, let me show you another. This is the last question I have for all of you. This is a very common looking device that I'm very sure we see with carpenters and people who work with surfaces and have to have straight surfaces. So this device, when it's kept on an even surface, the bubble is right in the middle. When the surface is uneven and it's raised to one side, the bubble moves to the side where it is raised. That information is given to students here. Then the student is asked that this device is placed on a newly built floor and the bubble moved to one side. That means that the floor is uneven. And if it moved to this side, that means the floor is raised towards this side. And now the question is asking, if I pour water on this floor, which side will it flow? So now if it's raised on this side, water is going to flow in the opposite direction against the slope, correct? And so the correct option is A. So the question did not require students to have any prior knowledge, right? This is what we were talking about when Hetal was saying there are few questions that are purely skill based. They don't require prior knowledge. This question, the previous one, just based on the information that's provided, you have to answer the question. And only 31% got the answer right, went in for option A. The other students have picked B, C, and D. It's indicating that there could be a confusion. Either that's one, they were not able to extract information properly. Maybe they didn't understand the question. That could be another reason. A few others would also be students who did not go ahead and read the question also. They must have thought, oh no, it's too long. I'm not reading it, and just picked any answer. So this skill of extraction, which we all agree is extremely important, NEP suggests it, NCF talks about it, and we're trying to introduce this, build this in the classroom. It's very important to understand that we cannot do this overnight, right? It is something that needs a lot of practice, has to be slowly built, right? So, Hetal, at this point, is there any way that you can suggest, because you work with schools so much, where how do you introduce these skills and also take care that you don't take up too much extra time in the
Surely,
classroom?
surely, Akanksha, there is. So when we say discuss concepts in the class, for example, when we are teaching students about fertilizers, it can also be useful and also very relevant to students for studying the data related to that concept, right? It may not be there in the textbook, but the web and given the generation we are dealing with, right, we'll have several authentic sources of related data. So what we do is we use that data and ask questions that require students to interpret the data. So at this point in time, you can actually plan the topics wherein you can do that at the beginning of the year. And we can also do this exercise in groups, which will help develop collaboration and communication also as the skill. Can we actually have a look at a few questions and the data? So this actually shows the number of flowers on various plants with and without fertilizer. So we can ask these questions: at what inferences can you make? Is the effect same in all of them? Which plant shows the highest increase? And through this, we are actually just helping them build a lot more skills of analyzing and critical thinking as well. Okay. So now, to make the remediation truly effective, we at actually at EI we believe that it needs to start very quickly. So just within a few days of the test. So the EI Asset Early Remediation Workbook is purely designed to help teachers to do exactly that. It highlights key observations from students' response, pinpoints common misconceptions, so teachers can actually use this workbook to prioritize areas that need immediate attention and plan strategies for improvement. It also includes clear next steps and space to track progress, making it a practical tool to close learning gaps early. In short, this workbook ensures that mistakes made in the test become definitely stepping stones for stronger understanding. Also, to help with this, we do have a lot of resources in the which is called the EI Asset Solution. We do have a website which we can see on the screen, wherein both teachers and students can easily access the correct answers to every test question. And more than that, this site also provides detailed explanation so students understand why the correct answer is right, and it helps teachers identify misconception, and students definitely get a chance to learn from their mistakes. And that is the real aim, right? It is a diagnostic test, it is not competitive in nature, wherein we definitely look at real learning with understanding. Simultaneously, you can also scan the QR code and access the same. Adding to the resources bit, we also provide misconception posters which are available. We've donated 10,000 plus questions on the Diksha platform. We have something called as an AQAD, that is an asset question a day. So what I usually recommend my schools is like how we have thought for the day. Why don't you put it as an asset question a day and let them actually do the thinking? And we also have the MCQ guideline, which is designed in collaboration with CBSC. So this is the snippet of, again, the misconception poster. Where can you find it? It's freely available and you can find it on the Diksha platform. And we also have practice booklets, and you can also again find it on the CBSE website, wherein we like purely concentrate on competency based practice questions. We also additionally do a lot of webinar series, this being one of those. And again, we have a lot of upcoming webinars for various subjects, and again, concentrating on specific grades. You can find it under CBSE training unit, and also you can find it on YouTube at the EI channel. So now, like when I had started the session, right? Let's look at a successful case study of a school. Say we call the school as ABC. Can we have the next slide? So here, what we see is a lot of numbers here are in red. What does that mean? The school is below national average, and this was the data of 2021. But when year on year, we did see a school taking asset and implementing the exact remediation and targeting the misconception, we do see that the slight improvement in math as well as Hindi, wherein other grades did come in within the average. And at year three, which is the year 2023, we do see that they are above the national average and it's all in green. And they were also in top 10 in the national benchmarking. Now, coming to the end of our webinar, the last thing we have is something we called as ATS, that is Asset Talent Search, which is definitely a prestigious test, and it's conducted by invitation, which is a top 15 percentile of our children scoring the mark. That has been identifying gifted students since 2010, right? What makes it unique is its culturally inclusive and globally focused approach, allowing students from diverse backgrounds to be recognized. So instead of rote memorization, we actually concentrate on critical thinking. And most importantly, definitely acts as a gateway to future global opportunities, helping children showcase their talent on an international platform, opening doors for academic growth and success. So with this, we can conclude the webinar here. A very small request for all our participants to please scan this QR code and give us a feedback. We are here all trying to create a world where children learn with understanding. Thank you all for your time, requesting everybody to please scan this and give us a feedback. Thank you all. Simultaneously, you can also like access the link which is in the chat box. You can click that and give us a feedback if you're unable to scan the QR code. Teachers, any questions you all have, please also feel free to put it in the Q&A box.
I'll just take this question, Sharbari ma'am. The NCRT books changing does not have a very large effect on the content we are creating because asset is not concept based, it's skill based. We are looking at concepts that the NCF suggests that students of a certain grade level should have. And we don't really look at what each textbook is covering, but we're majorly looking at what are the skills and what are the broad concepts that students should be doing up to a certain class level in order to create questions.
Requesting everybody to please give a feedback once it is done. And if you have no questions, you can leave. Thank you. Thank you so much, everybody, for your time.
In case of any more questions, please put them in the Q&A tab. Okay. Thank you so much, everyone, for being a part of this webinar, for listening to us, even though we've exceeded the time a little bit, but being patient and also for your questions that we've tried to answer as many as possible. And we hope that this is going to help you when you go back to your classroom and interact with students and plan your lessons. So thank you very much for being a part of this.
Thank you all. Thank you.
Thank you so much.